The population of bacteria is growing according to the equation. Estimate when the population will exceed 748. So the dependent variable P represents the population. So I want to know, when is it going to be at 748? Equals 550 e to the 0.11 t. Now we got to solve for t. We're good with that? That's the step. On the right side, I would like to isolate the power. So I'm going to divide by 550 on each side. And so now I've got 748 over 550 equals, now I've got the power isolated. So depending on how you think about this, you could either rewrite it from exponential to logarithmic. That's one option. Or for me, I just take a natural log of both sides. So if I do that, the natural log of e is going to cancel after I move the power out in front. And so, tell me if this is too many steps at once. On the left side, natural log of 748 over 550 equals 0.11 t. Divide by 0.11. So t equals.
I'll just make sure you're right.
The thing about this one, it may not take it here on this one because it says, oh no, it should be fine. You should probably be able to type it just like that. It says accurate to at least one decimal place. For me, if I don't want to do this with my calculator, I would just leave it like that and type it in exactly like it is. Because some of them are really picky about how many decimal places they need. So just leave it in logarithmic form where the log is my answer.
Sorry, it's taking me a minute. It won't let me. Every time I try to do, let me just do it this way. 7, 4, 8.
Yeah, there you go. 0.11.
Oh, you were right.
You don't say. Questions on this one? This is from 4.4.
Part 2.
Yeah. So as we're wrapping up, you should be able to do all of Unit 4 by the end of this week. And the 2 point, what are the other ones that we've already done? 2.3 and 2.4. But that should all be wrapped up by this week because after Thanksgiving, we're going to start Unit 5. So you should be able to finish all of that by now. If you want to start looking at it, I think you could work every problem in the Canvas already.
She's okay.
Yeah, I know it. I just don't want to deal with it right now. I stepped on it and made me realize it. So let me see if I can remember from scratch. In what year was the population of Capital City double that of January 1st, 1970? So I'm going to first start by writing what was the population in 1970. How could I write that? P of 20 equals 68,532 times 1.03 to the 20th. And so while I could plug in and find the number, I don't really want to do that. I just know the left side of my equation represents whatever the population was in 1970. So now if I need to figure out what year was the population double this, if I'm going to double this number, that means I'm going to multiply P of 20 times 2. Do we follow that logic? I'm doubling P of 20. And now then I need to know how many years in the future T that is. So let me see if I can. 68,532 times 1.03 raised to the 20th plus t. Because I need to know how many years in the future, so that's the t I'm looking for. I know it's from the starting point of 1970. How many more years do I need to go so that I can double what it was at 20? This made sense in my head. My head's weird though.
Couldn't
Okay.
you solve, like, just plugged in what you got?
Yes.
And doubled that and then set it equal to this problem?
Sure.
Okay.
That's another way that could work. So again, not the only way. There's always different ways. This is just what my brain went to and how I had to rationalize it. So now from here, I really want to do math on both sides of the equation, but I can't because I really can't do math with this garbage, P of 20. But I know what P of 20 is. It's that. So I could plug that in for P of 20. So now I've got 2 times 68,532 times 1.03 to the 20th equals 68,532 times I think this is actually different than the way I worked it last time, but maybe I can still get there. Okay, so I just put 2 times P of 20. We're good with that step. And then here I use my exponent rules. If I have 1.03 to the 20th plus t, I can rewrite that as 1.03 to the 20th times 1.03 to the t. Because what do I do when I multiply powers with the same bases? You add the exponents. So I'm going the other direction. Now, why would I want to do it this way? Because if I'm trying to isolate t, now I have a single variable. So if I'm trying to isolate this power, why is this power not by itself? Because it's being multiplied by garbage. You see that? So what do I need to do if I'm multiplying by garbage to get rid of it? Divide by garbage. Well, guess what's going to happen when I divide by garbage over here? You see that? It's the exact same garbage on both sides. Yeah? So then that leaves me with, and here is where the work that the people worked out for me, this is where theirs starts. Theirs says 2 equals 1.03t. Now, there may be some reason that I know I can go straight here, but I don't know it. That's why I had to go through these steps to rationalize it. So you may want to know for future, if you need to double the number of years, you could look for 2 equals that. Because these steps are always going to work out. Whether I'm tripling the years, quadrupling the years, all that is always going to cancel on both sides. And it's going to leave me with this statement. But when they gave me that as the first step, I didn't trust it. I didn't know where it came from. I needed to prove it to myself. So that's where this comes from to me. But this is where they start. So maybe I can remember that, but I doubt it. For future times. I'll probably always have to do this. Can we solve from here now? I'm looking for t. T is stuck in the exponent. How can I get t out of the exponent? I can log both sides, or you could rewrite it in exponential form. So this is going to be the natural log of 2 equals t times the natural log of 1.03. Right, if I'm taking log of this, I move the exponent to the front in line. Now I can do regular algebra with it. T is being multiplied by the natural log of 1.03. So I'm going to divide by the natural log of 1.03. So T equals whatever that is. So if you want a real number approximation, you could put that in your calculator. If it wanted an exact answer, what I have given is an exact answer. There's nothing wrong with that as my answer. But I don't have a calculator, so let's see about how many years that is, if I can find the notes where they work this out. It's right here. It says 23.445. Is that what you guys get if you plug that in? Has anybody plugged it in? So T is 23.445. Which means, what's really the question? The question is, what year was that? So if T is 23.445, what's the year? $1993. Probably June 29th. Maybe June 30th.
Okay.
Right?
I mean,
Could y'all figure that out? Yeah. Because I'm almost 23 and a half. Is that 445 or 495? It's 445, isn't it? It's probably not that close to the end of June. It's probably mid-June. June.
17th?
Yeah, I was going to go 15th, but. P of T equals 68,532 times 1.03 to the T. Could be written as, there's another example, where the rate of growth is 3% per year. Compare the graphs of P of T equals 68,532 times 1 plus 0.03 to the T, annual growth. And here's another continuous growth. Discuss the similarities and differences in their graphs. So before we plug into our graphing calculator, what do these look like, these functions? Like, does this remind you guys of anything?
The percent. No, what's? It's a formula that you can always calculate.
What's that for? Yeah, you're all over it. Yeah, it's a compound interest formula where A equals P times 1 plus R over N. So in this case, the N would be 1 raised to the N 1 times T. So this means it's compounded once per year versus this. How did we get this formula with an E in there? Yeah. So what's continuous? Over here in this formula, the N, the number of times it's compounded, is infinity. So remember, as N approaches infinity, that number approaches E. I showed you that. It was the day I wasn't here that I had to record where E comes from. So this just means we're compounding it continuously versus here compounding it once. So what do you think the graphs will look like before you ever plug anything in? Like, do you have any ideas going in? Great. That's great. It's wonderful. It's a good thing because, like, this class, we don't talk a lot about graphs and knowing what they look like anyway, so it's no big deal. That's all we talk about. It's pre-cal. They have the same vertical stretch. Yeah? What did we learn about the more times something was compounded? Was that good for my money or bad for my money?
No, it's good.
It was good. The more times we can get something compounded, the more money I make. That's where decimals come from. Because greedy people in the olden times, I don't know when it was, they said, hey, the more decimals we have, the more money I make in the long run, so let's keep adding these decimals. That's why they eventually switched from Roman numerals to the Arabic numerals that you're used to using. You don't care. Why am I even telling you all this? Europeans like the Roman numerals. Why did Europeans like the Roman numerals? Because that's all they'd ever known, right? Roman Empire spread everywhere, all over Europe. So the Roman numerals are everywhere. And they wouldn't change to the Arabic numerals until they realized that they could make more money. Greed. Unbelievable. Okay, so if I type in 68,532 times 1 plus 0.03 raised to the t versus 68,532. So they should have the same y-intercept, right? Because they have the same a value, times e division sign. Is there? I can't see. E raised to the r t. So I expect this one to be higher as time goes on because that's where I get more money from. That's a great window. You guys see what's going on there? Where's my y-intercept at? 68,532. I might need to change that window. What do you think? So what's the lowest y I care about? Yeah, pretty much 68,000. So what do we want the y max to be? It's going to grow exponentially. I don't know, 1,000,000. I'm just guessing. You always act like you got to have the perfect number. I don't know. It's 1,000,000. That may be terrible. Yep, too much. Window. Let's go 100,000 then. Delete. Graph. That doesn't even look exponential to me, does it? What does it look to you guys? Looks linear. So I'm going to need my x's to continue growing. So if I go to window, if I make my x max be 100, and I may need to make my y max be a little bit more, so I'm going to go to 300,000. I don't know. That looks more exponential. See how, I mean, are you following why I'm doing what I'm trying to explain? No, just no, okay. That's cool, whatever.
We're following.
Okay.
We're all here.
So,
Learning very much.
which one of these graphs is on top? Which one's the higher y value? It appears the red. Can I say that definitively? Yeah, I don't know.
I believe in that.
So if I go to zoom, I can zoom in. So you can do zoom in or zoom box. Zoom box is new, so I didn't use that as much when I was a kid back in my day. So if I go here, if I zoom in on this part of the graph and click enter, now I can more clearly see that the red's on top of the blue. See that? Yeah. So if I go y equals, which one was the red one? Yeah. So, how would you compare these graphs? What's similar about them? They're both exponential. How else are they similar? There's one more big thing, how they're similar. Same y-intercept. Right, they have the same initial value. That'd be the main things I would look for. How are they different?
The continuous graph grows higher than the norm.
It's a right idea, wrong word. Don't say it grows higher. You're right, it's above it.
Grows more exponential.
What's our x value we're talking about? Put it in context. The x's was, what do the x's represent?
What's the population? No.
No.
Nope, it's time.
Yep. The y values was the population. The x value is time. So if the y's get higher, quicker, right? It grows,
Continuous is growing at a faster rate.
that's it, or grows more quickly. Let's see how they word theirs. They say, oh, you can't see my iPad. Switch back. The graphs start at the same value, that's y-intercept, right? One thing that's important. But the continuous growth grows faster than the compounded annually. And how do we know it's compounded annually? Because the end value was 1, which means we're compounded once a year. Annual, semi-annual would be twice. Monthly, 12, weekly, 52, daily. Unless you really want your money, then it's 365.25. I'm a nerd because there's leap years. Okay, anyways, not that big of a difference. If your window's not just right, they may look like the same graph. So you see how we had to fidget with the window, make it look like what I wanted to see. Are there questions about the window part? So like, I never was taught how to use a graphing calculator because everyone didn't have a graphing calculator. So everything I tell you about is just what I figured out when I got a graphing calculator. Does that make sense? So like, I don't know how to present information to an entire group about a graphing calculator, but I can answer individual questions. Cool, okay, yeah.
I
If you have to-
could do it, I just don't, with you sitting here holding my hand through it, I don't think I can do it myself.
Which part could you not do?
Um,
Can you type them in?
what I get
The window. It's all the window. Did you get why I started at 68,000 to start with?
I would've figured
And then I just guessed $1 million. I was purely a guess. And then what happened when I guessed $1 million? I couldn't see the graph. It was too high. So I need to lower my Y values down. So that's why I went to 100,000. But then it looked linear. So I needed to see more to the right. Like, I still don't know if I had the perfect window in the end. Like, I probably wished I had the Y's up a little bit more. Because if you... I didn't take a picture of it. But my normal graph, like, we run out of space halfway over on the X's. It's like if I wanted a better representation, I could probably do higher Y's. If I go higher Y's, then they look even more like the same graph because it's more zoomed out. So it's just all you can't be scared to just fidget with it. You're not going to break it, right? The window. One thing that I have realized the more I teach is like people are afraid to be wrong, and so like you don't want to fidget with the window, or you don't want to manipulate the equation and just do random stuff to it. Because what can you do to an equation? Anything you can do to both sides. Whether you mess it up or not, you can still make the math work. But most people are paralyzed by fear. They are scared of what to click on so you don't even try anything. You just assume. Is that a real thing? Am I just making that up? Are you paralyzed by fear? Is that the problem? Like, I don't know what to click, so I'm not gonna. Oh, don't mess up. I don't know. I may be wrong. That's my guess, though. Do you guys know how I learned how to edit videos? Yeah, I just started editing them. You know how I figured out what dimensions to make my wiffle ball field? Just fix them, and if I didn't like it, I changed it. Try to make it fit. That's more of a philosophical problem I have.
all your life savings in that.
Yeah, that'd be, thanks. You want me to end up on the street. Write the exponential growth equation for y equals a times e to the bx given the following table of values. Paralyzed by fear?
No, we're good, we're thinking.
You just plug in
Okay.
100 equals, I don't know what the A is yet, but never mind. No, can't do that.
Paralyzed by fear. Look. Oh, stop. Oh,
Well,
ooh,
I was-
don't mess up.
Well, I was thinking about it, and I was like, well, that's not right. So
What's not right?
I'm not going to say it again because it's not right.
I don't think you said anything wrong.
Wait, like 100 equals, because that's a Y. Did you do that?
Is 100 a Y value?
Yes.
A, E, B, A, E to the B,
A, E to the B.
2. But I don't know what A or B is.
Okay. That's a good start. So we have 2 unknowns here. So how do I solve where I have 2 unknowns? Okay. So if I wanted to find the y-intercept, I'd have to plug in 0 for x, but I've already plugged in 2 for x. So this is not a bad thought, but I'm missing 2 things that I know nothing about either one. Anybody else have thoughts? I have a thought. I don't know if my thought's right or not. Like, I've not looked at but I have a thought. Do y'all have? Okay. That's good. Which one do you want to isolate? Okay. So if I wanted to isolate A, okay, I could divide by E to the 2B. Yeah. I'll do that over here. I don't hate that. And so now A equals 100 over E to the 2B.
You can plug that back in, and then you have only B variables.
Okay, yep. Where do I need to plug it into?
Where the exact.
Okay, but if I plug it in, where? Like this one?
Yeah.
If I plug that straight back in here, how many unknowns am I going to have?
B. You only have B. I don't know.
Only have... Okay, let's just look. So that would be y equals A.
100.
So you don't want to plug it in here,
I'm plugging into that one.
into here.
Yeah, is that right or no?
100 equals 100 over E to the 2B. E to the B times 2.
Yes.
So what do I really have here? I have E to the 2B times E to the 2B. Numerator and denominator, so what would happen? Yeah, are you good with that if I put this over 1? And so then I'm left with what? So not a bad thought. Can anybody, yeah, not exactly. Can anybody relate what you've just done here? That's so close. That was good. You made one mistake in all that math. This is what you've essentially done. You've taken an equation with 2 variables. You isolated for one of them. And then what did you do with this? To the same line. This is a line, and you're plugging it into the same line.
Do I need to switch to the 300 equals?
Because when I have 2 unknowns, how can I solve with 2 unknowns? I need a system of equations. I need a second equation that I can plug this x into it with a different y-intercept, a different slope, and find where the 2 lines intersect. System of equations. So what we needed was 300 equals A is 100 over E to the 2B times E to the B times X, which this time is 4. Did I do too many steps at once, or are you following? How we got there? Everybody good? Now it's e to the 2b times e to the 4b. If they were times, I guess I said it wrong. This is in the numerator, this is in the denominator. So you know how that simplifies?
Oh, you just gotta subtract.
Subtract the exponents.
So it'd still be E to B.
E to the 2b. So this would be 300 equals 100 times e to the 2b. Now what? Divide by 100. So that leaves me with 3 equals e to the 2b. And then what? I'm in. Natural log of 3 equals 2b. Because, again, I'm trying to shortcut stuff because I'm running out of room. So stop me if you don't understand. I natural log both sides. The natural log of e to the 2b, I move the exponent out front. And then I had the natural log of e, which cancels. That's 1. So I drop that. Is everybody with me? B is being multiplied by 2. So now I'm going to divide by 2. So b is the natural log of 3 over 2. And now what do I know? Once I know one part of a system of equations, once I know one coordinate, I plug it in and solve for the other unknown part. Gosh, man, I'm really running out of room. Are we okay? I know I'm all over the board. I hate it. But I need to record myself. I don't know. So this would be 100 equals A, I don't know, E to the B.
Why do we have to do it again? I thought we already found A.
We didn't find A. We found,
But I thought we found A first.
we did, but A was in terms of B.
I see.
What do you do when you do a system of equations? We solve for X in terms of Y. And then once I plugged in, I could find X, or I could find Y. Then I have to go plug in the Y found to find my new
Okay.
X. So you got options. You can plug in anywhere. I was plugging back into the original. I guess I could have plugged this back in here where A is already isolated. That's probably the easier place to plug in. I probably picked wrong. So if I plug this in for B here, does everybody understand I'm changing my mind? Where I want to plug in? So this would be A equals 100 over E raised to the 2B, and B is the natural log of 3 over 2. So all that's in the exponent. So I'm multiplying in the exponent, so I could put this over 1. Put the 2 over 1. We following? I can cross reduce. 2's reduce. And so that leaves me with 100 over E raised to the natural log of 3. So let me focus on this part very quickly. Just think through what this is saying. This is saying, really, I don't know the answer, right? If I've made it like a exponential. So this would be log base E of I don't know equals the exponent. You follow my logic? And so, what is log base E?
Natural log.
And so this is the natural log of what equals the natural log of 3. So what's the thing I'm looking for? Do you follow that logic, how that worked out? So I know when I have e raised to the natural log of 3, the e and the natural log cancel, and it's left with just the 3. Left with just the argument. It's like, I don't have to do these steps anymore. I can go straight from here to here. But this is the why. So now I know A. So I know A, and I found B. So let's write our equation for any x and y. Not just the ones that I had in the table. So this would be y equals A times B. No, sorry. A times E raised to the B times x. This will simplify. So I'm going to do that.
They just cancel.
Not easily. So, what do you guys see when you look at the exponent? I know what I see. Yeah. So, that's the first thing I thought. I was going through what I was going to do in my head. The division by 2. So, do I have a rule about division in the exponent? It's the other way. Subtraction in the exponent can be rewritten as division of the bases. It's like addition in the exponent can be rewritten as multiplication of the bases. But this is not subtraction in the exponent, it's division in the exponent. So I went away from the division first, and I looked at I have multiplication. So I have a power. This is being multiplied. So how can I multiply exponents if it was originally a power to a power? You follow that? I don't know if your calculators will do that. That's why I'm... Let me see what answer they got. If it's left like this, I'm going to leave it. But if not, I'm going to simplify it. They left it. I'm stopping. Are we good? That's going to be a whole big ordeal. Here's their answer. That's what we have, right? 100 over 3 times e raised to the natural log of 3 over 2 to the x, or times x.